and welcome to my videos on schizophrenia. This video is on biological explanations. There'll also be videos on the psychological explanations and biological therapies and the interactionist approach. It's a really good idea to watch the videos before you come into class because it means that you've got a good understanding of the content before, which means that we can work on your understanding of evaluation and exam technique. So this video is about biological explanations of schizophrenia. Schizophrenia seems to run in families, as do many mental illnesses. If you have a family member who has a mental illness or has suffered with a mental illness, then their offspring and whoever they pass down their genetic material to are more likely to develop a mental illness. However, we can't say that there's a cause and effect relationship there because families share so much of the same environment. You know, they eat the same foods, they go to the same places, they live in the same house. So although they share a great deal of their genetic material, we can't say definitely that there's a genetic cause of schizophrenia. However, psychologists have found that the higher the genetic similarity between family members, the more likely they are to develop schizophrenia. So, for example, if you had two identical monozygotic twins, one of them developed schizophrenia, the other twin would have a 50% likelihood of developing schizophrenia, and that's with 100% of genetic material shared. So that suggests that schizophrenia is not entirely genetic, because they only have a 50% likelihood of getting it. Because they share 100% of the same genes, you would think that the other twin would definitely develop schizophrenia, but they don't. In fraternal twins, they share 50% of the genetic material, so non-identical twins, and if one of them develops schizophrenia, the other has a 17% chance of getting schizophrenia. Likewise, in the textbook, if you have a parent who has schizophrenia, you as their child have a 6% likelihood of getting schizophrenia. So it's really not entirely biological or genetic because, like I said before, if it was, your chance of getting it would be 100%. So it's thought that there are some candidate genes for schizophrenia which may cause or increase the likelihood of developing it. So you may have the gene for schizophrenia or the genetic likelihood of getting it, but something has to sort of trigger that. Schizophrenia is what we call polygenic, which means that it needs multiple genes in order. You have to have a multiple array of genes in order to develop schizophrenia. Ripke et al. In 2014 looked at 37,000 patients compared to 113,000 controls and found 108 separate genetic variations for schizophrenia. So that's 108 different genes can cause schizophrenia. So really, people who have developed schizophrenia have really lost the genetic lottery. It's so unlikely. There's got to be so many different combinations of specific genes and specific environmental factors, and therefore to develop it is really unlucky, really. So the main hypothesis of how schizophrenia So the main hypothesis of what causes schizophrenia is called the dopamine hypothesis, which you may have heard of before in psychopathology. The dopamine hypothesis is this idea that neurotransmitters, specifically dopamine, appear to work differently in patients with schizophrenia. There's two main hypotheses which are called hyperdopaminergia or hypo. Now, if anybody knows anybody with type 1 diabetes, you'll know that hyper means your blood sugars go up and hypo means your blood sugars go down. And it's the same with the theory for schizophrenia. So hyperdopaminergia means that your dopamine levels have gone too high and hypo means that they've gone too low. So the first is hyperdopaminergia in the subcortex. This is the original theory that high levels of dopamine in the subcortex, which is like the central areas of the brain. So this would be excess dopamine receptors in Broca's area. Now Broca's area is related to speech. There's two areas for speech, which is Broca's area and Wernicke's area, and these are both in the right hemisphere of the brain. And so if there's too much dopamine in Broca's area, this means that it can contribute to impaired speech and auditory hallucinations, which obviously people with schizophrenia are suffering from. Hypodopaminergia in the cortex. This is an updated theory which focuses on abnormal dopamine in the cortex of the brain. And Goldman-Rahik et al. In 2004 found low levels of dopamine in the prefrontal cortex, which is this part of the brain. The prefrontal cortex enables us to develop our thinking skills, and it's specifically for decision making. And so Goldman-Rahik found that there was a link between low levels of dopamine in the prefrontal cortex with negative symptoms of schizophrenia. Another biological symptom of schizophrenia, another biological explanation of schizophrenia is neural correlates of schizophrenia. Now, don't forget that neural means the structure or the function of the brain, and so it's to do with how the brain is working. So we're going to look at negative symptoms and positive symptoms of neural correlates of schizophrenia. The first is a negative symptom, which is called avolition, which is the loss of motivation. Now, we all experience a loss of motivation at times where we can't be bothered and we don't want to do this, but in schizophrenia, it's extremely low levels of motivation. Motivation, the process of being motivated to do something, we often give ourselves a reward for doing something that we don't particularly want to do. So it's half term at the minute. I've come in half term to film these videos for you guys. Wasn't particularly something I wanted to do on my day off, but I motivated myself by having a McDonald's breakfast this morning. So motivation involves the anticipation of a reward. This is controlled by the ventral striatum in the brain. Now, if anybody's heard of Casey's study, Casey was the marshmallow. Well, it wasn't. Casey's study was based on the marshmallow experiment. So the one where the kids have two marshmallows, or they have a marshmallow, and if they can wait 10 minutes, they can get another marshmallow. Casey worked on this experiment, and he found that those children who could wait for the second marshmallow were called high delayers, and their ventral striatum wasn't as highly activated. And so therefore they could delay that gratification and they could wait for it. People with low delayers have a high level of activity in the ventral striatum, which basically means that they cannot delay gratification, they need to have it now. So abnormality in the ventral striatum may contribute to avolition. So the loss of motivation, there's nothing to reward the person for going to work or getting out of bed, feeding themselves. There's just no motivation, there's no pleasure, there's no reward in doing that. Juckel et al. In 2006 measured activity levels in the ventral striatum in schizophrenics and found lower levels of activity than in the control group. They also found a negative correlation between activity levels in the ventral striatum and the level of negative symptoms. So a negative correlation is when one covariable increases, the other decreases. So in Juckel's scenario, they found that the lower the activity levels in the ventral striatum, the higher the increase of negative symptoms. The other explanation is of neural correlates is with the positive symptoms. Allen et al. In 2007 scanned brains of patients experiencing auditory hallucinations and then compared them to a control group whilst they were listening to a pre-recorded speech. This speech was either of themselves talking or was of somebody else talking. They found low levels of activation in the superior temporal gyrus and the anterior cingulate gyrus in the hallucination group. So the superior temporal gyrus helps to process sound, which could obviously explain the auditory hallucinations. And the anterior cingulate gyrus helps with processing emotion and behaviour regulation. And obviously one of the key symptoms of schizophrenia is not being able to regulate their own behaviour and emotions. So thank you for watching my video on biological explanations of schizophrenia. I hope that's cleared up some things and has helped make sense of the information. Any questions, just let me know or leave a comment. And thank you for watching.